Assalamualaikum sir, my project is to design an antenna for radar application and I am designing an horn antenna. Now I am selecting a new template and then microwave and then antenna. Now next waveguide, time domain should remain millimeter and frequency gigahertz. So I am simulating the results from 8 to 12 gigahertz. Now I am selecting E field, H field and far field. Now next, we already have completed before that we will do some working plan and boundary box. Now we are very good to go for the designing. Before that we need to calculate some parameter. For that I have this online calculator. Here I have included the frequency 10,000 megahertz and the desired antenna gain is 20 dBi. For that it has given me some values. So for taking these values I have listed all the necessary parameters here. Now I will input this value in the CST. So first I need to enter the value A, that is 22.5, then B, that is 11.2, then C, that is 25.4, then AP, that is 130, then BP, that is 86.5, then D1, that is 159, then D2, that is 164, then for the R part, that is 155, and the thickness of the material T equal to 2 mm. Now we have completed all the parameters entered. Now we will start the designing. First we will select the modeling and we will select it, then it will pass some component value, so we will name it as wave guide. Then the x minimum should be minus a by 2 for the center position, then a by 2, then minus b by 2, then b by 2, then c by 2, minus c by 2, then c by 2. Then the material should be the PEC as good for the antenna simulation. Now click OK. So we have got this box here. It is the waveguide part, or we can say throat of the horn of the antenna, where the signal will start to enter. Okay, now we need to align the local WCS for coordinating system mainly. So coordinating system setting it here. What we will do, this is our X plane, this is the plane A, this is the plane B, this is the dimension mainly, this is the dimension of A, this is the dimension of C, and the dimension of BA is A. Now what we will do, we will go for the W part. So we will click here, so we will transform it for W. According to the W we will input R value there, so we will make a distance of R. Okay, then we got it. So if we click OK, we got the coordinating system here. Now we will design the big part, the big surface here. So for that we will again click big face. We will name it horn. So the values should be changed as well, so that the U minimum should be minus AP by 2, then AP by 2, then minus BP by 2, then BP by 2. So the thickness, it should not have any thickness currently right now. So okay, now what we will do, we will select both faces and click lock part to connect these things. So for that we need to press we need to go for pick face, that is here. We will double click it and we will also select it, pick face. We have selected these two faces. Now we will click a lock to connect these two pieces. We will name it slope surface, something like this, slope surface. So nothing changed here. Okay, now it has created the whole antenna. Okay, now what need to do, we need to make these three things. If we go to the component, we can see horn, slope surface and waveguide. So we need to make these things together, these three things together. For that reason we will go to boolean and click add. Now we will start to pick face. Now if we click it, we need to pick face here, and then again pick face for this side. Okay, now we have picked the faces and go to solid shape tools and choose solid optical shapes, and it should not be outside of the thickness of T. Now we can see that we have created a hollow horn antenna with thickness of T and necessary dimensions. Now we will click it, and if we turn off the local WCS system, now our design has been completed. So this is the thing. Now we will add a port here. That is, for that reason we need to go to the simulation port and the waveguide port. Now before cancel, what we will do now, we will again pick face and we will pick this face, and now we need to go to the waveguide port and okay, now it is okay, and we can click OK. We can see that our waveguide port has been added. Now if we select the view, now we need to simulate that. For that we need to run the setup solver start. We can see what has been done. Now we have finished our simulation. Now we will go to the 1D result. For that we will select the S11 parameter. We will selecting the S11 parameter. That is the most important thing. So now we can see what is happening here. For 10 gigahertz we achieved. We will see it from the marker. If we select it, okay, now we can see that the 10 gigahertz frequencies, our S parameter is minus 29.17, almost 30 dB. So what does it mean? It is the return loss space beta, and with S11 with this S11 with this value at 10 gigahertz and the deepest loss of minus 42 dB near 8.3 gigahertz. We can see that if we change the marker, the minimum point, we can see that 8.2 gigahertz. We achieved minus 43.08. So that is ideal for FMCW radar switch with a minimal amplitude ripple. Okay, now if we go for the VSWR result, we can see if we again to minimum, which is at minimum point. Now we can move to 10 gigahertz. The horn is very well matched at across with the VSWR 1.07. This corresponds to tau 0.035 dB ms, that loss of 0.005 dB. Essentially all the transmitter power is delivered to the antenna. Now at 10 gigahertz we have achieved minus 0.0468, indicating the almost 98.9% negligible conduction and mismatch losses. Now if we see The shell. Now if we see another important result, that is, first we cut the ABS. Now we can see the ABS. For this we move to polar. We can find more data from this point, and the principal cut shows at 3 dBm at 19.4 dB with the first side loss of 14 dB, which is similar with the expected on the orthogonal cut. The peak gain is 90 to 20 dB height, suitable for forecast illumination and clutter control. A slightly longer flare can push slide loss to 22 dB. Now if we see how the thing is working, the antenna is working. If we go for the efficiency 10 gigahertz, and if we start to animate things with exchanging and control, exchanging and contour contour, now we can see how that is working. So it is now working process of this antenna. So if we zoom in, so now we can see that the animation shows the field expanding from the throat into the near planar, from the throat to the near planar phase fault at the aperture with smooth amplitude and mills ranging at the width. So this is the horn antenna for radar application. Thank you.